It's a pleasure to be here and talk about Atoma and how to unlock the future of AI on Sui. So I'm Jorge Antonio, CTO and co-founder of Atoma. And before I start, I would like to ask you guys, who has used ChatGPT today? You can put your hands up in the air. Most people, incredible. How much of you guys feel that you share too much of your personal data with ChatGPT? A bunch of hands in the air also, cool. That's why we are talking here, and let's explore how we can bring more privacy and more protection for the data, for users' data on Atoma and Sui. All right, so I want to start by showing a funny graph on how these open source models have been catching up quickly with the best closed source models. So everyone here seems to know about ChatGPT. You might also have get to know other models like Grok, Claude from Anthropic, and a few others. These are all closed source, so they are basically closed by some proprietary gateway from OpenAI, XAI, etc. But you also have open source models, right? Who here has heard about DeepSeek R1? All right, most people. Llama models, most people. So these are open source models, which means that their weights are publicly available. So you can go to the internet and download them, and that means that you can deploy these models locally on your own hardware infrastructure. And what's really incredible is that when we started this revolution of intelligence with ChatGPT 3 or ChatGPT 3.5, open source models were actually much worse. But nowadays, at this point in time, we are actually pretty close to the best models in basically, for example, Qwen this week has launched a new model, which is open source, and is basically comparable to GPT-03 and whatnot. So the gap is shrinking closely, and this basically provides a very big opportunity, right? I will explain why. So you have companies like Meta, DeepSeek, Qwen, basically releasing open source models. And now that you have these models accessible, you can basically, instead of relying on ChatGPT, you can, for example, interact with any other API that serves these open source models, right? You can host them locally on your local infrastructure. That said, hosting these models locally introduces a bunch of problems because these models are huge and you need very capable, very expensive GPUs to run these models at a reasonable speed, let's put it that way. But you don't need to rely on ChatGPT anymore. You have alternatives, and that's really important. And that's important both for the normal customer, retail customer, but also for enterprises that now they can basically protect themselves or their intellectual property from OpenAI, right? So, given this, Atoma is positioning to deploy these models at scale, but is making it so that you have something fundamentally important, which is privacy, data privacy. So for the end user, some of you have answered that you feel you are sharing too much with ChatGPT, and therefore you are providing too much of your personal data with OpenAI. But now imagine that you are a big enterprise, right? A company, a government, etc., and you have all these proprietary data that you don't want to share, in plain text with someone like OpenAI. And it can even be worse. Imagine that, for example, you are a healthcare company, you guys might know about Oura Ring. You are basically gathering all this data from user metrics, etc., about their health and whatnot. And I mean, if you are sharing this with OpenAI, they will know literally everything about each one of us, right? And so basically at Atoma, we basically have this triad, which is very important. Data privacy at the top. At the bottom left, we have scalability. So we want these systems to scale. And for example, this is something you cannot do if you deploy these models at home, because I mean, this infrastructure is pretty, the hardware is actually super costly. And it's cost efficient. So basically at Atoma, we are providing APIs that you can interact with the Atoma network, have access to open source models with data privacy, and very cost competitive. So we can be as competitive as any other like AI provider. And we are basically a decentralized network. What does that mean really in this context? So we have basically a bunch of like GPUs across the globe, right? These are like high-end tier GPUs. We deploy these models on them, and we make sure that these models are deployed with full privacy. Like no one can access your data. And this is, and basically, some technical problem. All right. So, and we are building our decentralized infrastructure on top of Sui. And Sui is literally the best blockchain due to its like fast finality, low latency, very cheap cost, etc. So I have here some architecture guide on Atoma. I don't want to overburden you guys with too much with this, but we used Sui blockchain for things like node registration, payment, settlement, global coordination, etc. Right? So imagine that you have like you are a data center, and you have basically access to high-end GPUs. You can monetize these GPUs basically with like minimal effort by just plug into the network by registering your node on the Sui blockchain, right? Our network is very modular. That means that every piece is very like independent in itself. So we have the Sui smart contract. We are connected to Walrus to basically provide like encrypted data, user data on Walrus that can be retrieved in context to provide like personal context to the interactions that users have with AI models. We have basically we also have uploaded some of the largest models on Walrus, including like DeepSeek R1. So now these models are basically there, can be, and you have like access to model weights that cannot be tampered in any way, which is also relevant. And then we use something very important here on the privacy and verification, which is like trust execution environments, TEs. Who here has heard about trust execution environments? A few hands in the air, that's amazing. So what are these? These are basically hardware solutions that they work like as a black box that protect whatever execution is running within this black box. And these trust execution environments is the way that we can bring privacy to end customers, both retail and enterprises, right? And so this makes Atoma provides basically private AI. And these trust execution environments, they need to be deployed both at the CPU, but also at the GPU level, right? Because your GPUs, they also need to, the AI workload running on the GPUs needs to be protected. All right, so, and scalability is also something very important, but basically just pertains to say that your network, your infrastructure can scale with the demand on time, basically. All right, so I already talked about a bit about this diagram, but just to give you like a very like summarized flow, you have a node. So a node is basically just a machine with GPUs, right? IN GPUs that have trust execution environments that we can deploy ourselves. You register on the Atoma contract. You need to submit some remote attestation together with a public key that is generated within this trust execution environment. So it cannot be accessed by anyone, including the node operator, right? And that's very important. And then you can basically query, like this public key is available on-chain. And so when you want to interact with Atoma, you have like some client or some interface that you can use to access a node public key and use that public key for shared encryption. So you basically are creating a channel, like a TLS channel, like a secure channel between the client and the node. So now the client can just, in a very simple and standard way, send requests to the node that are fully encrypted, and these requests are what we call OpenAI API compatible, meaning that they follow sort of like the standard in AI for interacting with LLM models. And then once you have like the public key from the node, you can send basically encrypted data to the node, and the node sends you back encrypted data that you can decrypt. And this is like full secure because everything on the node is running within the TE. So you cannot, like you will receive encrypted data, but you cannot decrypt it only within the TE, and the TE is protected by the node operator. So that's how we achieve privacy. So I will make a quick pause here if there is any questions about this diagram or anything else you want to ask. Well, I already see a few hands. Like just 2 quick questions. Maybe start here. Exactly. So inference is done on plain text within the trusted execution environment. But the private key for the decryption, it lives within the TE. So no one can actually extract the TE. Sorry, the public key that is within the TE. So, yeah, over there. Yeah, so the blockchain is actually fundamental in many aspects. So first of all, you want to have basically a transparent, immutable ledger so that these trust execution environment attestations are stored and can be verified. So you make sure that you are not trying to tamper with like the remote attestation and whatnot, right? So that's one key aspect. The other key aspect is to have alignment, aligned incentives between what, like the way that you host and you deploy these models and how you, in the future, will basically create new models and the community, the open source community, etc. So basically what we want to foster is basically accelerate open source development in a way that is aligned with communities, intelligence, etc. All right, so I will move on, and if anyone else has more questions, you can feel free to ask a bit later. So I want now to go more about like our community and how we are positioning ourselves. So we have released our DevNet that is available. And basically you can interact with Atoma today, have access to these models with our API, etc. So our DevNet, we did our launch in January 2025. Since then we have made significant improvements. So you can actually use it sort of in production. We can see here that we have a bunch of different projects building on our DevNet. 48% roughly it's on DeFi. You have some infrastructure projects, security, gaming, entertainment, social, etc. So, and all of these are on the Sui ecosystem, which is actually super exciting, right? We have roughly 100 projects that built on Atoma over the past few months, which is on our DevNet, which is really great. And we'd love to see more building and leveraging Atoma. So at the ecosystem level, we have a bunch of partners. We have more than what is showcased here. But we have like blockchain infra, including like Sui, of course, Linera, which is some also an L1 layer with a unique architecture. We have LLM gateways and aggregators like OpenRouter, LightLLM, etc. Agentic infra, we have Eliza OS, Talus, and many others. Navy, Sphere One, Aftermath, etc. on the DeFi and financial. We have gaming, social, Anomaly, Studio Mirai, etc. AI apps and compute providers like Ori, Atai, Compute Labs, Hydra, Host that are basically providing the GPUs for us. We're also working with other partners that are not listed here, Walrus, Tusky, and a few others. So let's, and right now our DevNet, it's actually, we are generating revenue, actual revenue, like real revenue. So for example, OpenRouter, we have plugged a bunch of models on OpenRouter, Llama, Mistral, and a few others. And we basically have a bunch of, have their integration, it's a paid integration. We have Linera, SingularityNet, FetchAI, Anomaly, etc. And so to get started, it's actually very easy. I will do a quick demo in a few minutes, but you just need to go to atoma.network, our main page. You'll be routed there to our cloud interface, and you can know more about like the infrastructure, the architecture, how to use it on the Docs Atoma network. All right, and that's it. Maybe I will do a demo, and maybe then we can go into some questions. Does that sound okay? All right, let's do it. So I will try not to mess up live, live demos are always like a bit crazy, but this is like our own page. You can click on Atoma Cloud. I already have it open here. So this is our usage on the network right now. over the past 7 days, we have processed roughly 1.7 billion tokens, LLM tokens, which is pretty incredible. So here we are making a call to Llama 70B, Llama 3.3. And you are basically using the same interface as you use on OpenAI, for example, to interact with their models. I don't know how many of you guys here use OpenAI API, but I see some hands. So it's very close, it's very similar. And so basically you can ask like some question to it, right? And basically make it run. So if you run you can get your API key from our cloud platform that I showed you in a couple of minutes. And here you can see that the request is being generated, right? So now what I've done here is if you guys, let's go back just a few seconds. So on the generation here, you see that we are using this chat to create a stream, right? So this is basically the same interface as OpenAI. For example, you can use the OpenAI client to interact with Atoma, same way. However, we have a different endpoint that we call confidential chat. And these, instead of sending the request in plain text, it will fetch the node public key, it will encrypt it, and it will send to its TE. So this confidential chat gives you full privacy of your data when you interact with Atoma. And you interact with it in exactly the same way as you would interact otherwise, right? So let's see how does that work. And you can see here that the speed is actually pretty good. So even with like the encryption, decryption, the public key fetching and all of that, you can achieve like a very fast response. Like you have very minimal overhead compared to the non-confidential one. So that's basically, it just shows that we can scale our infrastructure. So we have minimal latency overhead, which means that we can provide like very competitive costs compared to like other LLM providers with the additional guarantee of privacy and being connected to a decentralized network on Sui. And that's basically it. Thank you, guys. So I will open up for some questions, so let's do it.
I would like to ask about function calling or tools, how they may call them as well. Is it supported? What are the limitations?
Yeah, that's actually a very good question. So we support tool calling, structured outputs, vision models. So for example, the new Llama 4 releases, they are multimodal by nature. All of that is supported. And it's supporting the same, following the API standard of like nowadays, which is OpenAI API, right? So all of that is supported. So on the back end, we are using VLLM with some optimizations, which has support for all of these. And you're also using SGLang, which has very good performance. And so basically everything, like all the standard usage of LLMs is available on Atoma.
So regarding tool calling, do you also support internet, like Tavily search or any internet connection between the LLM?
Yeah, another great question. So Atoma, we offer the LLM, or we provide the LLM inference, right? You can build anything on top of it, right? So for example, we have an app, if I had internet, I will show you guys, which is called Utopia, that has web search plugged into it. So it uses Atoma to run the inference. So when you ask a question, it will answer you using the LLM hosted on Atoma. And then basically the web search is built in on the browser. So you can interact with the LLM via multiple API calls. And so you can ask the LLM what should it search for on the web. You search it, you get the response, you send back to the LLM to parse the result and send back to you. So that's definitely possible. The privacy is at the inference level. That said, you can have things like, for example, verifiable agents, like full end-to-end verifiable agents built on Atoma, which means that you have your agent, which is basically a scheduler, like a loop running within, for example, a TE, and like AWS Nitro Enclave, whose remote attestations can be now verified on-chain on Sui using Nautilus. And that can make API calls on Atoma that gives you the verifiability that the model that you're running is the exact model you have. So you can have all these like workflows built on top of it that increase the complexity and can give you like more interesting products and features, including web search, personalized AIs, personalized AI agentic workflows, etc. Any other questions? All right, I will.
Yeah, I guess I'm just wondering how you deal with latency in your decentralized GPU clusters, and how that sort of impacts the performance of your inference engine.
Yeah, so basically, if you like even in the record here, it will like the latency overhead is pretty minimal, and the way we achieve this is by basically we sort of like have a very optimized way to interact with the blockchain. So you don't need to interact with the blockchain for every new request. You interact with the blockchain to make a deposit, like the same way as you go to OpenAI and you deposit, let's say, $10 on their API, and now you can use it. You do the same with Atoma. We make the deposit on chain, and then the only synchronization that needs to happen on the Atoma network is between the nodes to know how many tokens each one of them is processing at a given time, which is very minimal latency. Then we have what we call the Atoma proxy, which is basically a cloud interface, right? That gives that we have seen in the UI before, that basically pre-selects the nodes based on their like real-time usage. So every time you send a request, the proxy already has an internal state of which node is more available, which one node is the fastest, the cheapest. And once it gets the request, it knows exactly which node can send the request to. So it's very fast. And then you establish a connection directly with the node, and then basically the streaming is like normal, the same way, it's the same speed as depends on your internet connection speed, but in the same way, it's basically the same as interacting with OpenAI or any other provider. So latency overhead is pretty minimal. Yeah, I think we still have time for one or two more questions. Anyone wants to give it a try? All right, one more.
You mentioned some competitive pricing. How do you achieve that? I mean, compared to other providers and.
Yeah, all right. So that's also a very reasonable question to ask. So we have seen that we have like sort of minimal overhead burden on Atoma. And so in order for you to establish a price for inference, what you care about is how many tokens you can process on a given time. And you want to batch as many requests as possible. Like in normal terms, like in practice, what we want is to have like highest GPU utilization possible, right? And so running these workloads on TEs, etc., the only overhead you have is basically the communication between CPU to GPU, which has to be encrypted, and GPU to GPU. But the connections between CPU and GPU to GPU are very fast, and encryption, decryption as well. So these introduce like minimal latency. And so we can batch as many requests as any other service, provided that you given like the same optimization algorithms, right? And so for Atoma, as with any other provider, it's not the data privacy, etc., that brings like sort of the bottleneck for the price. It's more about the algorithms, the actual running the inference that we are using. So right now we are using the LLM and a few others with some tweaked optimizations. And long term, we want to basically dive deep into this algorithmic low-level optimization of GPU inference to reduce further the costs and become as competitive with any like AI lab that has all these like closed source optimization in-house. And I think there was also another question over there, right? Any other questions? All right.
This is a more broad question. So you mentioned that ChatGPT and centralized solutions, they rely on user data mostly for monetization, and also there's other models. What are kind of the trade-offs in what you guys are building? Like with the applications that are using you guys, they have some kind of trade-off by being on the decentralized level. Can you talk about a little bit more about this trade-offs, and is this data thing also one?
Yeah, great question. So so basically one of the biggest trade-offs, the way I see it, is once you plug with Atoma, you are basically you can only plug into open source models, right? So you might prefer Grok or ChatGPT or some other model for a specific use case that you don't have an open source model that can be like a reasonable alternative. That's one case, right? Another, but honestly, in terms of like the way that open source models are catching up quickly, I think that's very little burden. I think also the trade-off will be in terms of how much features and applications on top of it can be shipped compared to OpenAI. So OpenAI they are doing one thing which is great with execution. They have been releasing new features like crazy, right? They have the image model with Ghibli, photos and images, all that stuff. And that's it's difficult to compete at this level of execution. It goes beyond the LLM inference, right? Our hope is with a strong tokenomics, strong partnerships and go-to-market, we can foster the open source community and the Web3 community to bring in some really cool applications, maybe some cool tokenomics attached to it that can be competitive with Web2 alternatives. And I think we are on time. All right, thank you so much, guys. It was a pleasure.